Hello students. All right, we've got a recorded class today because I'm out of town, so I hope that you found this lecture video without any trouble. Let's go over a couple of announcements here before we get into the material. First of all, the homework assignment number 8, that's due today if you're watching this video on Monday. It's due Monday, February 28th by 12 p.m., so that's noon. Upload it to MU Online, and if you've got any questions along the way, feel free to send me an email. I'll do my best to respond. Also, as a reminder that we're going to continue to use Excel quite extensively over the coming lectures, and so please bring your laptop computer to class. In particular, we're going to have a quiz on Wednesday in which you'll need to have a laptop computer available. So please bring your quiz on Wednesday. And also, I'd like you to bring the in-class exercise that we're going to be working through in this video. I'd like to give you points for having completed it and going through the activity. The topic of today's video is, first of all, an illustration of why we shouldn't, in general, compare projects according to the internal rate of return. This is an illustration that will show that sometimes the IRR of one project would lead you in a different direction than what the true value of that project actually is. The other thing that we're going to be talking about is the first overview of what incremental analysis is, and just to kind of start the juices flowing so that you can understand the more detailed incremental analysis that we're going to do on Wednesday. So I've emailed you a PDF copy of in-class exercise 21, and what I'd like you to do is pause this recording and work through each of the questions that are asked here. So you're going to need to start Microsoft Excel, set up the table as it's shown, and you can calculate the internal rate of return pretty easily using the equals IRR function in Excel. Then in part B, I'm asking you to compare these two alternatives with the present worth method. So in other words, find out at the MAR of 4%, what's the present value of each project. And then the illustration and the comparison that we're going to draw is, in step A, where you were comparing the IRRs, and step B, when you were comparing the present worths. What would that lead you to believe? So short answer is pretty important that you be able to explain these concepts and ideas. So please pause the recording now, and then after you've done steps A through D, then unpause the recording and you can go through the solution as I've worked it online.
Your first two columns of the spreadsheet, well, first three columns of the spreadsheet are shown there. You're going to need to calculate the internal rate of return for both projects and also the present worth of both projects to try and find out what looks better versus what definitely is better. Remember, if you were not warned about the challenges of comparing internal rate of return, the one with the highest interest rate may seem like the best alternative to you. But what we really want to do is maximize profits. I got a lot of extra handouts. I think that means people have started their weekend early. I'm glad that you're here today. It's the true believers that are in class today. We ought to have an attendance quiz, except for we're not going to. All right, so if we just looked at the IRRs, we'd get the wrong idea about how good Project A is. Because at first glance, if we're thinking about we want to have a nice high interest rate, it seems that Project A is pretty good. Here, Project A has an internal rate of return of 12.4%, and Project B has an internal rate of return that's lower, 10.28%. So all things being equal, you should take the project that has the higher internal rate of return. But here, not all things are equal. The main difference is that one of the projects you have to invest more, but then you get more revenue out of it over time. You know, it's $50,000 of the original investment versus $85,000. Now these guys are borrowing money. Let's assume that they are borrowing from the bank at the MAR, 4%. And so what this means is they're going to the bank and they're taking money and they are paying the bank back at 4%, but then they're going to earn either 12% on the overall investment or 10% on the overall investment. But here's where the two things are different. If you can borrow and then reinvest a small amount of money, $50,000, or a large amount of money, $85,000, it's better to invest the large amount of money. So we prove that by looking at the present value. And I showed like the two different approaches for finding the present value. One is by finding the present value of each individual year and then summing those. Or you can just use the NPV function, which you add just the future values to, and it discounts it to the present, and then you combine that separately with the amount that's already at the present. So either approach will give you the same value, but you know, the one that is best is Project B. Project B is best because it gives you the most dollars, and that's what you're really after when you're operating a business, is maximizing your profits. And so the reason why you get more dollars is because Project B costs more to begin with, but it gives you a larger return on that investment over time. So it's a little bit of a confusing thing at first to say, well, it has the lower internal rate of return and it's more expensive. So why is it better? You know, what makes it better? And the thing that makes it better is, yeah, it's more expensive to begin with, but remember, you're buying it with borrowed money. And so you're buying something and you have to pay 4% for the privilege of borrowing, but then that thing, that money that you borrowed is earning a return of 10.28%. So think of it more simply. What if you could go to one bank and withdraw money at 4% and then go across the street to their competitor, and their competitor is going to pay you 10.28% on your deposit? Well, you'd borrow as much as you possibly could under those circumstances. But what if you could only borrow $50,000 if you're going to put it into an account that pays 12.41%, or you can borrow $85,000 into an account that's going to pay 10.28%. And this is an example of where it's actually better to go for the lower interest rate if the account will let you put more money into it. And this isn't completely abstract, by the way. There are like real-world situations where this comes up. So for instance, earlier in the semester, we were looking at typical interest rates out there in the world. And one of the things we found was Everbank, which has what they're calling a yield pledge money market account. And they'll pay you 1.11% for a one-year period on a balance up to $250,000. And so if you deposit beyond $250,000, then it just goes to their normal kind of measly rate, which I think is around 0.4% or something. Now this other bank, by the way, is offering 5%. So it seems like, wow, 5%, and that's even for a checking account. So that's a little bit more convenient because you can access the money with your debit card, you can write checks against it. There aren't restrictions on the number of deposits or withdrawals in a month like there is for a money market account. So at first, this other bank seems like such a great deal, especially because they'll give you $50 on top of it. But then there's this little asterisk next to the APY. And I had to go really far down on the page before I finally found the information that that's only up to $5,000 and it's a rate that's valid for 6 months. And so if you could only have one account, you've got a big pile of money you need to put to work somewhere, is it better to earn 5% on $5,000 for 6 months or 1.1% on $250,000 for a year? And I had hoped I could calculate that and tell you, like, quantifiably which one is better, but then I got interrupted by a phone call. So maybe next year they'll know for sure. But I think you get the main idea. The conceptual difference here is that one of them has a pretty low cap on the amount they're willing to take and assign this tempting 5% return. I guess 5% on $1,000 would be $50, right? So it's $250 if it was for a year, but it's only for 6 months. So that's about $125 plus the $50 they're throwing in. So the value of it's roughly $175 of that investment. But 1.11% on $250,000, I think you're going to be making like $100 a month on that. So it's better to go with this one because of the limit. So if we think back about the in-class exercise, which of the two projects is better, you'll never, when you're picking projects, you'll never go wrong in just comparing the present worths or comparing the future worths. Now, incremental internal rate of return is what we'll get to on Monday, and that's a way of looking at how much more expensive one project is versus another. Any questions before we talk just very briefly about incremental analysis? Any questions about this illustration? What about the short answers? Here's how I put it for the short answer to the question of what does the present worth represent? Okay, the present worth represents the profit. So if you are going to be in the part of the problem where you're finding the present worth of this cash flow at 4%, you're paying the bank that you're borrowing the money from their interest. Then if you discount this cash flow diagram at 4%, this leftover $22,998, that represents what your benefits for doing the project are, the present worth of those benefits. And so it's the money that's left over. And not surprisingly, the higher the interest rate is from the bank that you're getting the money from, the smaller your profits are going to be. So, you know, a greater fraction of that amount is going to the bank instead of to you if they charge 5% or if they charge 7% and so on. So on part C of the in-class exercise where it says explain which project should be selected and why, you should select project B. And the reason why is that's the project that will return the greatest profits to you. But then as a concept question, if you have to borrow money at the MAR, the present worth represents the profits that you get to keep, the present worth of the profits you get to keep after the bank's portion has been satisfied. So the main lesson that we've learned from doing this in-class exercise is that you can't compare a project by the IRR and from that necessarily know which project is better or worse. Now sometimes you can. It was just this example, I had to sort of be a little bit careful about how I created it. I had to make sure that it was pretty close so that one of them had a high IRR and the other one had the higher present worth. Oftentimes, the one that's better will have both the present worth that's the best and the higher IRR. So it's not that you should always choose the one with the lower IRR. It's just this is a special illustration of how IRR alone isn't going to tell you which one is best. Now, The one exception to this rule is the one that I've already explained to you from the homework, is if the original investment amounts are the same, then you should choose the one with the highest IRR. Because the whole reason that the difference arose was because of the different original investment amount. All right, so on Monday, what we're going to do is calculate something called the incremental internal rate of return. And an increment is the difference between two alternatives. And so in this illustration, we've got option A and option B. And it looks like option B is more expensive, but the reason why you'd buy the more expensive one, potentially, is that it has lower operating costs over time. You have to pay $19,000 per year instead of $25,000 per year. So at first glance, it may be the better alternative, especially because it seems to have a higher salvage value at the end of its useful life. Now, we're not actually going to calculate which of these two options is better, but what I want to illustrate is the idea of the increment. And so what you do in incremental analysis is you subtract the value for each row of the higher, more expensive alternative relative to the cheaper alternative. And so sometimes we'll compare 5 or 6 options to each other, and the way that you should organize them is from cheapest on the left to most expensive on the right. And then your comparisons are going to be in an increasing original investment amount. So here, the incremental cost is $20,000. And for that $20,000 more that you would pay for option B, the incremental benefit is $6,000 per year. Those are savings for expenses that otherwise you'd have to pay each year. And the incremental salvage value is $2,000. So the backside of the in-class exercise is pretty easy. I mean, if you know subtraction, you'll do just fine on it. But the point is to sort of lay the groundwork for the incremental analysis that we're going to do in class on Monday. And I guess one of the main things I'll reiterate is that when you're sorting alternatives, you always put the cheapest on the left and the most expensive on the right when you begin your comparisons. So calculate the incremental amount comparing project B to project A on the back of the page. All right. So for these two projects, option B is $35,000 more expensive, and it has an incremental benefit, an incremental revenue of $5,000 per year. So what we'll do on Monday is we're going to say, is it worth it? Is this extra $5,000 each year worth the $35,000 that you have to pay up front? And the only way we know is depending on what the interest rate is. Because remember, money in the future is worth less than money today. So you're going to be shelling out $35,000 in year 0. Well, all of these future amounts may not be worth very much if you have a high inflation rate.